Hello and welcome back to another video. In this problem, we're told that a crystal growth furnace is used in research to determine how best to manufacture crystals used in electronic components for the space shuttle. For proper growth of the crystal, the temperature must be controlled accurately by adjusting the input power. Suppose the relationship is given by T of W is equal to 0.1 W squared plus 2.155 W plus 20, where T is temperature and W is power. So in part A, we're asked how much power is needed to maintain the temperature at 200. So if T is 200, what is W? So we have this formula, or this equation rather. We have 0 is equal to 0.1 W squared plus 2.155 W minus 180. There's a couple ways you can solve this. You can graph it, you can plug it into a calculator, but no matter how you want to solve it, quadratic equation, you'll get that W is equal to 32.998. This is the power required to maintain the temperature at 200. If the temperature is allowed to vary from 200 by up to 1 degree Celsius, what range of wattage is allowed for the input power? So if we have 199 being the temperature, solving for W again, we get 0 equals 0.1 W squared plus 2.155 W minus 179. Solving for this, we get W equals 32.884. And for 201 going 1 degree in the other direction, this is another equation that we can solve. Subtracting 201, 0 equals 0.1 W squared plus 2.155 W minus 181. W here is 33.112. So if you go 1 degree in one direction, this is the wattage. If you go 1 degree in the other direction, this is the wattage. Therefore, the range for W has to be less than 33.112 and greater than 32.884. So in the definition of the limit as x approaches a of f of x equals L, what is all of these things? So if we have the limit as W approaches 32.998. As W approaches this value, the function T of W, the temperature, approaches 200. So X is W, f of X is T of W, A is 32.998, L is 200. And what is the value of epsilon that is given? Epsilon is the degree to which the function can vary from its value of L. So here we're told that it can vary up to 1 degree, so epsilon is 1. The corresponding value of delta is the degree to which W, the variable of the function, can vary based off of the limit that epsilon puts on it. So if we take 32.998 and we subtract 32.884, we get 0.114. And if we take the other value and we find the difference between it and 32.998, we also get 0.114. Therefore, if you go 0.114 away in the variable of W, that will restrict the temperature to values that are no more than 1 degree Celsius in each direction. So the corresponding value of delta is 0.114.